Okay, I'm going to go ahead and unpause and start this section. We're going to do 6.1 and start 6.8 today. 6.1 is on what are called radical functions. Well, the ones that we're going to be dealing with are square root functions and what they do on a graph, what they look like, and what moves them around, and what we use for their domain. Okay, the first thing we're going to talk about is the domain of a radical function, or a square root function to be exact, because remember when we were talking about those functions that had an x in the denominator, and we were talking about the domain, there had to be that restriction, right? Because what was in the denominator couldn't equal 0. So that gave us a restriction in the domain because we didn't want the denominator to equal 0. Well, now we have another restriction that we need to investigate, because remember when you're dealing with a square root, you don't want what's underneath a square root to be negative, right? Because that brings up the i's, the imaginary numbers, numbers that aren't on a number line. So what we need to make sure is that when we are plugging in numbers for x to plot points, we need to make sure that we keep what's underneath the square root positive so that it's not negative. And you'll see what happens in the y equals when we do that. It's going to give us an error message. So what is under the square root needs to be positive. Another way to say that is greater than or equal to 0, right? That's what makes you positive, is if you are bigger than 0. If you are less than 0, you are a negative number. So that's what we need to steer clear of, are any numbers that make what's underneath the square root turn negative. So let's look at number 1. F of x equals the square root of 5x plus 8. And it wants me to find the domain of this function, which means if I am choosing and making an XY chart to plot different numbers to plug in for x to give me a y, so I'll have numbers to plot on the number line on the XY graph, I want to make sure that I'm not going to get an error message, because 5x plus 8 needs to be greater than or equal to 0, right? If it's not, then it's negative and it's not going to work. So just whatever is under the square root, just say, set it up as an equation and say greater than or equal to 0 to solve it. So if I solve this, I'll need to subtract 8 from both sides. So now I have 5x. It's greater than or equal to negative 8. And then divide both sides by 5. So x needs to be greater than or equal to negative 8/5 in order for it to work. If you plug in a number for x that's below negative 8/5, it's not going to work. It's going to give you an error message. So let's see, we've talked about different kinds of graphs. X graphs just make lines. X squared graphs, which we've talked about, make that U shape, right? Absolute value graphs make a V shape. Let's look and see what we're going to see when we graph square root graphs. So let's just graph the standard one that doesn't have any other numbers involved with it. It's just the square root of x, and see what that gives us. If I go to my y equals in my calculator and clear it out and type in square root of x. So to get to square root, you'll hit your second button. And if you come down to the x squared button, you'll see right above it is the square root symbol. So you've already hit the second button. So once you hit that square root button, and put the x underneath there. So square root x. Let's graph it. So there's what it's going to look like. Let's see why. Let's plot some points. Go to second table to get your points. Now, look up. Do you see what happens when your x is below 0? Like -1, -2. Do you see what's happening? It gives you that error message, right? Because x, what's underneath here, can't be below 0. It can't be a negative number. So since it's just x, it can't be a negative. I'm gonna pick some numbers out of this XY chart though and plot them on a graph. So let's see, I'm gonna plot the point 0, 0. That looks like a good one. 1, 1. I'm just going through and picking out numbers from the table that don't have decimals. So I can do 4, 2. I can do 9, 3. Let's plot these 4 points, right? So if you go back to the graph, you should get a graph that looks like that when you plot those 4 points. So let's see, I'm going to plot the point 0, 0. So right at the origin. That's where it's going to start. Then I'm going to plot the point 1, 1. So my x is 1 and my y is 1. So I'm going to go to the right 1 and up 1. There's another point. Then I'm going to go to the right 4 and up 2. For this point, so to the right, 1, 2, 3, 4, up 2. And then the last point I'm going to plot is 9, 3. So to the right, 9, and then up, 1, 2, 3. So there is what your square root function looks like on the graph. Now, it's going to follow all of the same rules of transforming. Or transformations. Remember that section that we did where sometimes the graph moved up or down, sometimes the graph moved left and right, and what made that happen? Remember, what made the graph left and right? That would be inside numbers. Move your graph left or right, but you go opposite the sign, right? So if I had x minus 2 here, it would have actually moved it to the right 2. Outside numbers, move the graph up and down, and you go with the sign. Okay? So let's see. Oh, and one other thing. What's going to make a graph steeper or less steep? That would be what if there is a number hooked on or multiplied in front of this square root graph. If the number is greater than 1, if it's the absolute value of it's bigger than 1, like 3 or 7, it's going to make this steeper. If it will be a fraction, like 1/2, it's going to make it less steep. So that's what's going to make the graph steeper or less steep. So let's see what some of these transformations do. Look at number 2. The only thing different on number 2 that's making it not be just the standard square root of x graph is they put a 3 in front of it. 3 times the square root of x. So I'm going to leave the original square root graph up there, and then I'm going to plot points from this graph to see how it is compared to this. So I'm going to go to my y equals, clear it out, and type in 3 second square root x. Graph it. So you see how it's a little steeper. Let's see why. So I'm going to go to the table. So second table, let's get some points that don't have decimals. Again, once I get below 0, it starts giving me the error message, right? Because what's underneath here, it's the same thing. It's still just x, so it can't be below 0. So I'm going to start off with 0, 0. That's still part of the graph. Let's see. This time the points are 1, 3, 4, 6, and 9, 9. So let's plot those 4 points and compare it. I'm going to draw this one red so I can compare it and see what this 3 did to my square root graph. So let's see, I still have a point at 0, 0, so that hadn't moved. But my next point is at 1, 3. So to the right 1 and then up 3. My next point is at 4, 6. So to the right 4, up 1, 2, 3, 4, 5, 6. So you see what's happening here? It's making that 3 made that square root graph be steeper. And my last point is at 9, 9. So I will go to the right 9 and then up 9. So that's what 3 square root of x would look like. So since this is multiple choice and you are looking at A, B, C, D, and E, A, B, C, D, when you're doing this in Math Lab, you will have a little magnifying glass next to each of those multiple choice options. So if some of them are very similar, you should be able to get rid of some of them. Like I can get rid of definitely B, right? It's not going in the right direction. So it's either A, C, or D. And again, you'll be able to blow up those graphs to see which ones cross through that point, those points, which looks like it would probably be C, right? The one is C is the one that went steeper. All right, number 3 is -2 square root of x. So this, if we remember our transformation rules, what happened when my x was negative? So here's my original. With the x being negative, it should flip it upside down, right? That's what the x being negative is going to do, is reflect your graph across the x-axis, or in other words, flip it upside down. So let's see why that happens. So type in -2 square root of x in your y equals. And let's graph it and see if it flips upside down. Which it does, right? It goes below the x-axis. The x-axis now, it flipped it upside down. Let's see why, but from our numbers looking at. Okay, again, anything below 0 is going to give me that error message because I still just have an x underneath here, so I can't be below 0. So let's see what are some points on this graph. 0, 0 is still on there. Let's see, 1 now goes with -2, 4 goes with -4, and 9 now goes with 6. So let's plot these 4 points. Again, I'm leaving the standard square root one up there so you can see just what this -2 does to it. So I still have 0, 0, so I still have that point. But then I have 1, -2, which is going to make me go to the right 1 and then down 2. So there's why it flips upside down. 4, -4, so to the right 4 and down 4. And then 9, -6, so to the right 9 and then down 1, 2, 3, 4, 5, 6. About right there. So it flipped it upside down and made it a little bit steeper because of the 2. The negative flipped it upside down. The 2 is what made it have a steeper shape. So let's see, what would that be? On number 3, looks like as long as you knew your transformation rule about it reflecting across the x-axis, you would know the answer, right? There's only one of those that reflected it across the x, which was A. All right, number 4 is the same exact problem as number 2. I don't know what happened there. Maybe lucky. So let's go to number 5. All right, number 5 is f of x equals the square root of x minus 6. So before we graph this or do our XY chart, our error message is going to start somewhere different now. Why is that? On the first 3 problems, the error message started right at -1, right? Anything that was right below 0. Because on the first 3 problems that we did, all that was underneath the square root was the x. But now I have x minus 6. So let's see, where should our error messages start? What is underneath your square root needs to be greater than or equal to 0, right? That's what it just needs to be positive. So what's underneath there needs to be positive. So if I solve this for x, by adding that 6 to both sides, I now see that x is going to need to be greater than or equal to 6. So let's see how all this ties together. This minus 6 is an inside number, right? If it's underneath the radical, it's an inside number. Outside numbers would be outside the radical over here. Well, if it's an inside number, what should it do to this standard square root shape? Inside numbers transform you left and right, but you go opposite the way the sign is telling you. So this minus 6, when I look at this in my numbers, it should move the graph to the right 6. That's what the transformation rule says. Inside numbers move you left and right, but a minus actually moves you to the right. So let's look at this on the graph. Clear it out. Second square root. And underneath your square root, you need x minus 6. And then hit graph. So it should be the standard square root graph, move to the right 6. So let's tie this all together. Why is the domain of this one x has to be greater than or equal to 6? Look at your shape. Look where the graph starts. Starts right there where the x is 6. If you go this way on your x-axis below 6, are you on the graph? No, your x, anything below 6 is not included in that graph, right? That's what the domain told you before you even graphed it. you're only going to have x's bigger than 6. If you're below 6 on the x-axis, you're not included in this graph. So let's go to second table and get some points. And look what happens. Where my x is 6, that's still good, right? That's a point. But look, if you go below 6 to 5, what does it tell you? It's an error message, right? So it all ties together. The graph is going to start over here at the 6. Any numbers below 6 are not included. That's why numbers below 6 in your x give you an error message. So let's get some points that are on the graph, like 6, 0, 7, 1. Let's see, 10, 2. Let's just do those 3. So let's see, my first point is at 6, 0. So this time, since my x is 6, I'll go to the right. 1, 2, 3, 4, 5, 6. I don't go up or down at all. Since my y is 0, so I'll just put it right there. That's where the graph is going to start. Let's see, my next point is 7, 1. So to the right, 7, and up 1. And my last point that I'm going to plot is at 10, 2, which will be to the right, 10, and then up 2. So you'll see that that minus 6 did exactly what the transformation rule said it was going to do. It moved this shape to the right 6. So again, this is multiple choice. So if you knew your transformation rule, there's only one of those graphs that had traveled to the right 6, correct? All the other ones did something else. All right, let's look at number 6. What is it? Square root of 2 plus 2x. So let's see, but it doesn't tell us to find the domain, but I like to tie it all together to see what I know for sure is not going to be included in this graph. So 2 plus 2x needs to be greater than or equal to 0. If not, it's going to be an error message, right? Your x will be an error message if it doesn't fall in this category. So if I'm solving it for x, I need to subtract the 2. So now I have 2x needs to be greater than or equal to negative 2. Divide both sides by 2 here. So x is greater than or equal to negative 1. So when I'm looking at my XY chart, negative 1 is going to be okay. Negative 2 is going to give me an error message. Right? Anything below negative 1 is going to give me an error message. So let's go to y equals and type this one in. Second square root 2 plus 2x. Let's graph it. So it looks like it moved it to the left a little bit. What is the lowest thing that my x could possibly be? Negative 1. Look where it moved it. To where x was negative 1, right? On the graph, look where it starts on the x-axis. It starts at the very lowest thing that x can possibly be, which is negative 1. So let's go to second table and get some points so we can graph this. I'm going to start it at negative 1. So negative 1, 0. 1, 2 is a point. And let's see, another point would be 7, 4. So let's plot those three to see where this goes. So it starts at negative 1, 0. So where my x is negative 1. There's another point at 1, 2. So to the right 1 and up 2. And then there's another point at 7, 4. So to the right 7, 1, 2, 3, 4, 5, 6, 7, and up 1, 2, 3, 4. So where did this graph start? It started on the x-axis at the negative 1, right? That's what that's where when I found the domain and I found the very smallest thing that x could be, that's where it's going to start. Okay, so that'll help you in finding this. Well, it looks like the only one that even looks anywhere remotely like that would be that A. All right, last one before we go into 6.8. 8x minus 8 is what's underneath my square root. So let's type this one in to see some points on it, to see what it's going to do to my square root. So y equals second square root 8x minus 8 and graph it. So this one starts on the number line, the x-axis at positive 1. So why do you think that is? 1 is the smallest thing that x can be. Let's see why. 8x minus 8 needs to be greater than or equal to 0. So if you solve that one for x, you would have to add the 8. So 8x needs to be greater than or equal to 8. If you divide both sides by 8, x needs to be greater than or equal to 1. Okay, so that's the smallest thing that x can be is positive 1. That's why it starts where x is positive 1. Let's do second table and get some points. 1, 0 is my first point. 3, 4 is my next good point, right? I'm trying to just avoid all those decimals. 9, 8 is another point. So 1, 0, the right 1, up and down 0. 3, 4 means to go to the right, 1, 2, 3, and then up 4. And then the last one is at 9, 8, which means go to the right 9 and then up 8 to draw in. So look at the difference if you're looking at the A and B. One of them starts at negative 1 and one of them starts at positive 1. Remember, this one started on the x-axis at positive 1. All right, so that is all of 6.1. We're going to start 6.8, which is on what is called piecewise functions. What a piecewise function means is depending where you are on the graph, you have a different function going on. They look different. If you're looking at these right here, do you see how it starts off by going down and then it goes straight across and then it goes up? This one does all kinds of different things. It goes straight across, then there's a piece that goes up, then there's a piece that goes down, and then there's another piece that goes up. So that's what I mean by a piecewise function. Where you are, it's not the same function on the whole graph. It's not just an x squared function where you've got a U shape. Or it's not just a square root function where you have that shape. It's not just a line. Depending where you are across the graph, you're in a different piece or a different function. Okay, again, it can be all different shapes, right? This one has, part of it's an upside down parabola, part of it's a straight across. This part goes up, then it goes straight across again. So depending where your X is, it's going to be a part of a different piece of the graph. Okay, so we're actually going to do the very beginning of this, 1, 2, and 3, and then we're going to do 10 and 11. We're going to skip the graph part of it. We're going to do that on Wednesday. Okay, numbers 1, 2, and 3 are going to give you a function. Each function is going to have 3 pieces. So number 1 looks like this. F of x equals x minus 1 for when x is less than negative 5. F of x equals 3x for when x is between negative 5 and 2. So that looks like this. Negative 5 less than or equal to x, which is less than 2. Now, the third piece is f of x is x squared for when x is greater than or equal to 2. So I've got 3 different pieces. If the x is less than negative 5, it's a part of this piece of the graph, where x is x minus 1. If x is between negative 5 and 2, it's part of the 3x piece of the graph. If x is greater than or equal to 2, it's going to be a part of the x squared part of the graph. So what number 1 says is identify the expression that should be used to find f of negative 3. So what I do is ignore this part right here and come find the piece where x is negative 3 fits into. So let's see, is that less than negative 5? Be careful with that. Let's look at where these numbers are on the number line. Negative 5 would be here. The other number that's represented is 2. So there's 3 parts of the number line represented here. This is actually an x, think about it as your x-axis. When x is less than negative 5, that's this part of the graph, right? There's where x is less than negative 5. When x is between negative 5 and 2, that would be that part of the graph. When x is greater than or equal to 2, that's that part of the number line or the graph. So what is it wanting me to find? Negative 3. Where would negative 3 fall? Below negative 5, between negative 5 and 2, or above 2? It would go between the negative 5 and 2, right? Negative 3 will be somewhere about right there. So, what does that mean? If it's in this piece between the negative 5 and 2, it's in this part of your graph, the 3x part. So that's how you do those. You find which piece your x falls into, then it goes to that part of the graph. So let's look at number 2. Same kind of thing, different function. Number 2, f of x equals, again, there's 3 different pieces. F of x equals 4x for when x is less than negative 5. F of x equals x minus 8 for when negative 5 is less than or equal to x, which is less than 3. So pretty much means between negative 5 and 3. And f of x equals x squared for when x is greater than or equal to 3. So there's my 3 spots. It wants me to find what part of the graph should be used to find f of 15. So where does 15 fall in these pieces? Is it less than negative 5? Nope. Is it between negative 5 and 3? No, it's 15. It's not between negative 5 and 3. Is it greater than or equal to 3? Is 15 greater than 3? Yes, which means it falls in this piece. So which part do I use to find f of 15? Since it falls in this piece, I will use x squared. And the last one of these. Brings up something a little new that we haven't seen. Again, it's got 3 pieces. F of x equals x minus 7 for when x is less than negative 2. F of x equals 6x for negative 2 less than or equal to x, which is less than 3. And f of x equals x squared for when x is greater than or equal to 3. And it wants me to find, identify the expression that should be used to find f of 3. So I notice when I come over here and look at my 3 separate pieces, is that I have 2 of them that have that 3. This one says x is less than 3. Well, 3 is not less than 3. What is 3? It equals 3, right? So that's why you want to choose where x is greater than or equal to 3, since we are using 3 as our number. So x equals 3 in the last part, which means which piece would I use? X squared. Now, I'm going to jump and do 10 and 11 because they go right along with this, okay? It actually takes it to that next step. It says, okay, if I was going to do this one and actually find f of 3, the first thing you have to do is go find which piece it goes in, which it goes in this bottom piece, right? Since x equals 3. So that tells me that I go to, and I plug it in for x squared. So if I was actually going to do that to this last problem, I would put 3 in place of that x, which would give me 3 squared, which is 9. That's what we're going to do on 10 and 11. Find out which piece to plug your number into, and then plug your number into that piece. So let's go to number 10. G of x, there's only 2 pieces to this graph. G of x equals x plus 9 for when x is less than or equal to 3. And 6 minus x for x is greater than 3. So I'm finding 3 different things here. I'm just going to do 3 different numbers. The first thing it wants me to find is g of negative 6. So again, I'm just going to take this one step further. I'm going to find the piece where negative 6 fits into, and then I'm going to plug it into that piece. So let's see, where is negative 6 in my pieces? Is it less than 3 or greater than 3 or equal to 3? It's less than 3, right? Negative 6 is less than 3, which means negative 6 goes in this piece. So it goes in the x plus 9 piece. So now it just wants you to plug it into that x. So let's see, what's that going to give me? Negative 6 plus 9, which is 3. So again, you see what it's doing? It's just taking it one more step. You find the piece that it goes into, and then just go plug it in that piece. So find g of negative 6. Now the next thing it wants me to find is g of 3. So this is where we need to pick, right? They both have a 3. So which piece does it go into? If I'm finding 3, I need to find the one that says equal to 3, which is which one? That top one. It's got the equal to bar. So if x equals 3, I put it in this top piece again, so it's also going in the x plus 9 piece. So if I put a 3 in for x, I'll have 3 plus 9, which is 12. And then the last thing I want you to find is g of 7. So same thing. Where does 7 fall? Well, it's not less than 3. It's greater than 3 this time. So it falls into this bottom piece, which is 6 minus x. So that's the piece that I'm plugging the 7 into. So if I plug 7 into there, I have 6 minus 7, which gives me negative 1. All right, number 11, last one. H of x has 3 different things. The first piece is negative 4x minus 9 for when x is less than 6. Negative 6 for x is less than negative 6. Just plain old 5 for when negative 6 is less than or equal to x, which is in less than 5. And x plus 2 for when x is greater than or equal to 5. We're going to find 4 different values. First thing we're going to find is h of negative 8. Where does negative 8 fall into? Which piece? Is negative 8 less than negative 6? It is, right? It's below negative 6 on the number line. So it's going to fall into this first piece. So if I plug it into my first piece, let's see, I'll have negative 4x minus 9 is my first piece. Replace that x, so I have negative 4 times negative 8 minus 9. Negative 4 times negative 8 is 32 minus 9, which is 23. thing it wants me to find is h of 2. So which piece does 2 fall into? Is 2 below -6? No, it's above it. Is 2 between -6 and +5? Yeah, right? On a number line, 2 would fall somewhere between -6 and +5. So it goes in this piece. Look, what is this piece though? If you fall in that piece, your answer is simply 5, right? There's no x to plug it into. So if you are between -6 and 5, your answer is just 5. There's no x to plug into there. It's just plain old 5. H of 5. Let's see, where does that fall into? Be careful here. I see 5 in 2 spots. I need to find the one where it equals 5. So you're looking for the equal to bar, which is down here. So it's in that bottom piece, which is x plus 2. So I'll replace the x in the x plus 2 piece with 5. So I have 5 plus 2, which is 7. And the last one it wants me to find is h of 8. Where does 8 fall? Well, it's greater than 5. Since it's greater than 5, it falls in this bottom piece, which is x plus 2 again. So replace that x with the 8. So I have 8 plus 2, which is 10. Okay? Now, when we start on Wednesday, we're going to do the middle part of this, and we're also going to be able to do 5.4, I think. Sometimes I say that and I can't get it in. But our goal is to finish 6.8 and then do 5.4 on Wednesday.